warahmatullahi wabarakatuh dan salam sejahtera. My name is Afira binti Ahmad. Today I want to introduce to you about colloidal chemistry. So, what is colloids? Colloids is a type of mixture that falls between homogeneous and also heterogeneous. If you can see here, there are three pictures, which is true solution, colloidal solution, and also suspensions. Which the colloidal solution in the between of the true solution and also suspensions. The particle size of true solution is less 10 to the power negative 7 centimeters. Next, for the colloidal solution, the particle size is 10 to the power of negative 7 to 10 to the power of negative 5 centimeters. And for suspensions, the particle size is greater than 10 to the power of negative 5 centimeters. Colloids have two types, which is dispersed phase and also dispersed medium. So for the dispersed phase, we call it as a solute, and while the dispersed medium, we call it as a solvent, which is the dispersed phase in a smaller proportions, while the dispersed medium in a larger proportions. For example, as milk. We know that the milk is a combination between a liquid phase and also water. So for the liquid phase, it was a dispersed phase because in a smaller proportion, while water is a dispersed medium, which is the larger proportion. Next is 8 types of colloids and the examples. For your information, there are only 8 types of colloids, which is the first one is gas, in the dispersed phase in gas. And for the dispersed medium in liquid, so the name is foam. And for the example as soap foam and also cream. The second one is gas, and dispersed medium is in solid. So the name is solid foam. For example, like rising polyester. Next is in liquid. For the dispersion phase liquid and the dispersion medium in gas, the name is liquid or aerosol. And for example, as fog and liquid spray. Next is a liquid and liquid. The name is emulsion. And for example, like milk and also hay cream. And next is dispersion phase in liquid and the dispersion medium in solid. So the name is solid emulsion. For example, as dispersion phase in solid. So if the dispersion medium in gas, so the name is solid aerosol. And for example, as smoke and dust. And for dispersion medium in liquid, the name is salt, gel, or paste. For example, as toothpaste or jelly. So next, for the dispersion medium in solid, the name is solid soil or solid gel. For example, as pigmented plastic or colored plastic.
Next, we go to concept of colloid chemistry. Colloid chemistry have two types. First is leophobic. Leo means liquid and phobic means heating. So, leophobic is liquid heating. Leophobic colloid have no affinity for the dispersing medium and are not solvated. They are stabilized by charged environment by preferential absorption of ion. If water is the dispersing medium, they are known as hydrophobic colloid. For preparation of leophobic solution, it has two methods. First, condensation method. Condensation method in colloidal chemistry is by combining a very small particle into the colloidal particle. The process can be in chemical reaction or solvent change. Chemical reaction process is double decompression, oxidation, reduction, or hydrolysis. Second method is dispersion method. Dispersion method is by splitting large particle of a substance into a colloidal size. This method can be made in 3 processes. First, colloidal blender, and second, British arc. British arc is suitable preparation of colloidal solution of metal like gold, silver, or platinum. Third is stabilization by the action of an electrolyte in solution.
We continue the presentation with the concept of leophilic salt. So basically, leophilic salt is salt that known as a solvent loving, based on the name of it, which leo means solvent, while philic means loving. The second point is the substance that's on mixing with the suitable dispersion medium readily form a colloidal salt. This salt is colloidal solution in which the dispersed phase or the particle in this salt have a very strong affinity with the liquid. This salt is a reversible salt, and the stability of this salt is due to the interaction between the particle in this salt. There are many ways to prepare this soil, such as by barium sulfate gel, solid ethanol, soap gel, sol or gel from gelatin, starch and jelly, and lastly with calcium carbonate or natrium chloride gel. They are also easily to be formed by only by mixing the substance like rubber, gum, gelatin, starch, or with any suitable liquid. The example for this type of soil is rubber and gelatin.
Now we go to how the concept was applied. The first one is in coagulation and flocculation process. Colloidal chemistry is crucial in treating wastewater and sludge through the coagulation and flocculation process. So, in coagulation, coagulants like metal salts like aluminium or iron are added to the waste for destabilizing the colloidal particles and allow them to clump together. So, flocculation involves the addition of flocculants like long-chain polymers that further aid in the aggregation of particles into larger flocks. These flocks can then be easily separated or settled up, facilitating the removal of suspended solids and impurities. Next, the concept also applies in waste stabilization. So, colloidal agents, often in the form of colloidal gels or binders, can be used to stabilize hazardous waste. This agent binds or encapsulates the toxic compounds to prevent their dissolution or leaching into the environment. The colloidal particles trap or immobilize the contaminants to reducing their mobility and the associated environmental.
Other than that is adsorption and ion exchange. Colloidal chemistry principles are employed for adsorption and ion exchange process in solid waste treatment. Activated carbon, zeolite, or other colloidal materials can be used to adsorb or exchange toxic and heavy metal ions that present in the waste. And lastly, while removing them from it, the concept also applied in immersion breaking. An immersion is a type of colloid formed by combining two liquids that normally doesn't mix. Colloidal chemistry is utilized to break down immersion formed during waste treatment, such as oil water immersions. Colloidal destabilizing agents can be added to break the emulsion, allowing for separation and proper disposal of each base.
From the conclusion that we can make is a colloid is intermediately between a solution and suspension. While a suspension will separate out a colloid will not, can be dangerous from a solution using ethanol effect. Light passing through a colloidal dispersion, such as smoky and foggy air, will be reflected by a larger particle and the light beam will be visible. So that's all from our group. Thank you for listening.